In our lesson today, we're going to begin by looking at the surface area of prisms. The surface area of a solid is the sum of the areas, of its outside surfaces. Okay, the first type of prism that we're going to look at is a rectangular prism, and a rectangular prism has 6 surfaces. Okay, so if we look at this rectangular prism down here, this rectangular prism, it has a top and a bottom. The top and the bottom. Okay, and the top and the bottom are congruent to each other, which means that they're the same shape and size. It also has a front and a back face. Front and back. And the front and the back are congruent to each other. It also has a right and a left side. Okay, the left and the right sides. Okay, and the left and the right are congruent to each other. In order to find the surface area of the prism, we're just going to add all areas of its faces. Okay, and so that's what we're going to do here with our first rectangular prism. Okay, I can see here that it has dimensions of 6 inches by 3 inches by 12 inches. All right, I need to figure out the area of each face of this rectangular prism, and I'm going to start with the top and the bottom faces. Okay, I know that the top and the bottom are congruent to each other. All right, here is the top face, and it's in the shape of a rectangle. To find the area, well, of course, I'm going to do area equals base times height. And the measurements, okay, we could see that this rectangle is 12 inches by 6 inches. Okay, so I can simply do area equals 6 times 12. Okay, and that's going to give me 72 square inches for just the top. Now, the bottom is also 72 square inches, so to get the total area for those two faces, I'm just going to double it. 2 times 72 is 144 square inches. Going to do the same thing now for the front and the back faces. Here's the front face, and I can see it's a rectangle again, so I'll use area equals base times height. And this time the measurements are 6 inches by 3 inches. So 6 times 3, which is 18 square inches. Okay, that's just the front face. The back is exactly the same. So once again, I'll double this. 2 times 18 is 36 square inches. And now I'll do the same thing for the left and the right faces. So here's the left face, the right face. And it's again a rectangle. Area equals base times height. For the measurements, okay, I know this height is the same as this height, which was 3. And this base down here is the same as this right here, which matches the 12 inches found right here. So I could do simply 12 times 3, which is going to be 36 square inches. But again, that's just for the right face. The left face is exactly the same. So once again, we will double it. 2 times 36 is 72 square inches. Now to get the area, or the surface area that is, I'm going to add all of these areas together. So SA for surface area equals 144 plus 36 plus 72, which comes out to be 252 square inches. That is the area of this rectangular prism. Okay, so if this were some sort of a box and we wanted to wrap it with wrapping paper, okay, the wrapping paper goes on the outside surfaces, we would need 252 square inches of wrapping paper to cover this box. So with our last example, what we did was find the area of each face of the rectangular prism and then added them together to get our answer at the end. We're going to try to develop a formula for the surface area of a rectangular prism. And again, you can do that by finding the sum of the areas of its faces. So we know that there was a top and a bottom, a left and a right, and a front and a back face. Okay, the top and the bottom faces are exactly the same. So whatever area I get for the top or the bottom, I'm going to have to double it. So I'm going to start out by doing 2 times something. Now, for the top and the bottom, they use the same dimensions to get their area. So if I'm looking at this prism right here, okay, to get this top face right here, I would have to do the length, L, multiplied by the width, W. So my formula is going to start out as 2 times the length times the width. For the left and the right faces, again, they're exactly the same measurements. So whatever area I get for one of them, I'm going to double it. So 2 times. And now the dimensions for the right face, I can see here's the right face. Okay, I need the width times the height. So I'm going to do plus 2 times the width times the height. And now I need the front and the back faces. Once again, they're congruent, so I'll double whatever area I get for one of the faces. Looking at the front, I need the length multiplied by the height right here. So I'm going to do plus 2 times the length times the height. So this formula can be used to find the surface area of any rectangular prism. 2 times length times width, plus 2 times width times height, plus 2 times length times height. So now that we have a surface area formula for rectangular prisms, let's use that formula to find the surface area of this rectangular prism down here. It has measurements of 15 meters by 2 meters by 5 meters. Okay, I need a length, a width, and a height for my formula right here. Okay, so I'm going to use this right here as my height, which is measured 5 meters. And then the length and the width really are interchangeable. It really doesn't matter which one is which. So I'll call 15 meters the length and 2 meters the width. And now I'm just going to plug these values into my formula. So SA for surface area equals 2 times the length, which was 15, times the width of 2, plus 2 times the length times the height. 2 times the length was 15, and the height was 5, plus 2 times the width times the height. 2 times the width was 2, and the height was 5. Now I'm going to follow order of operations. I'm going to do my multiplication before I add. SA equals 2 times 15 times 2. Well, 15 times 2 is 30, times 2 again is 60, plus 2 times 15 is 30, 30 times 5 is 150, plus 2 times 2 is 4, times 5 is 20. Now I'm just going to add up these numbers, which is going to give me a surface area of 230 square meters. Next, we're going to calculate the surface area of a triangular prism. Remember that the triangular prism has 5 faces. 2 of them are triangles. The triangles are the bases because they're parallel to each other. And then it has 3 rectangular sides. I've decided to call these rectangles A, B, and C. It really doesn't matter which one is A, which is B, which is C, but we'll get to those in just a moment. Just like with my rectangular prism, I'm going to calculate the area of each face of the triangular prism, and then at the end, I'm going to add all of those areas together. So let's start with the triangular base. In order to find the area of a triangle, remember that the formula said area equals 1/2 base times height. So I'm going to have 1/2 times, and now for the base and the height, remember that the base and the height have to be perpendicular to each other. Perpendicular means that they form a right angle. So on my triangle, I'm looking for a right angle, and I can see there's a right angle right here. Okay, there's where the right angle is on the top face. Remember that the bottom face is exactly the same measurement, so the right angle on the bottom face is going to be right here. Therefore, because that's where the right angle is, those two sides are perpendicular, my base and height are going to have to be 15 feet and 8 feet. So I'm going to do 1/2 of 15 times 8. Okay, and now half of 8 is 4. 4 times 15 equals 60 square feet. Now, that would be for just one of the triangular bases. Remember that there's 2 of them that are congruent, so I'm just going to double this. 2 times 60 equals 120 square feet. Now I have my 3 rectangular sides that I need to find the areas for. All right, so I'll do rectangular side A, which I'll kind of call this front face right here. Okay, so if I want in parentheses, I can call that the front face. It's a rectangle, so I know my formula is area equals base times height. And now if I trace this front face right here, its dimensions, well, I see down here, it's 15 feet by this height, and the height is the same as the height here, which is 20 feet. So I'm going to do 15 times 20, which equals 300 square feet for the area. Now, this rectangle is the only rectangle with that area, so I'm not going to have to double it or do anything else with it. I'm done with that rectangle. Rectangular side B, again, it's a rectangle, so I'm going to use area equals base times height. Okay, for this one, now let's do, we can call this, the side face, the right, if we want to call that, the right face. Okay, and so again, if I trace this, I can see it's 8 feet by 20 feet right there. So 8 by 20. 8 times 20 equals 160 square feet for the area of that rectangle. And again, that's the only rectangle with that area, so I'm going to leave that alone. And now rectangular side C, that's going to be this rectangle that's in the back, if I want to call that the back of the triangular prism. It's a rectangle, so area equals base times height. And now to get its measurements, I'm going to trace it. I can see right here it's 17 feet by 20 feet. Okay, so that rectangle right there is 17 feet by 20 feet, which is going to be 340 square feet. Okay, so now that I have all of the areas of the faces, the last thing that I need to do to get the surface area is add them all up. So surface area equals the two triangles, which was 120, plus my three rectangles, 300, plus 160, plus 340. And so that means if I add all those numbers together, I'm going to get a total surface area of 920 square feet. Okay, so once again, if I wanted to think about painting the outside of this triangular prism, okay, I would need paint that could cover 920 square feet. So just like with the rectangular prism, I want to try to develop a formula for the surface area of a triangular prism. The triangular prism, remember, was the sum of the areas of the three rectangles plus the two triangles. If I look at this triangular prism and use the measurements as labeled, in order to calculate the area of rectangle 1, and again, it doesn't matter which rectangle I call rectangle 1, I'll call this right side rectangle 1, I need to know its base times height. Well, here I can see it's labeled as L, the length, multiplied by this height here, which is called S number 3. So I'm going to do length times S number 3, side number 3. Plus, for rectangle number 2, I can call that this bottom rectangle down here. So I'm going to have this measurement, which is S2, or side number 2, multiplied by L, the length. So length times side 2, plus my third rectangle, which can be this rectangle over here on the left-hand side. Okay, well, again, that's going to be this length multiplied by this measurement, which is called S number 1. Length times S number 1. Plus now two triangles. So whatever the area I get for one triangle is, I'm going to have to double it. So 2 times, and then to get the area of a triangle, I have to do 1/2 the base times the height. Remember that the base and the height have to be perpendicular to each other. Okay, so I can see back here for this triangle, the base is labeled with B. So times B times H, the height, has to be perpendicular to that. And that's what they've called H right here. Okay, so this formula looks a little complicated. I'm going to try to simplify it a little bit. Okay, if I look at just the rectangular faces, notice that each face involves measuring with the length. Okay, if I factor the length out of this part of the formula, all right, surface area is going to equal the length times, all right, the sum of S1, S2, and S3. S1 plus S2 plus S3. And those measurements are the side lengths of one of the triangular faces. So if I take the three triangular, the three sides of the triangular face and add them together, All I need to do is multiply that by the length of the prism, and that'll give me the surface area of the 3 rectangles. Then I would have to add on the area of the 2 triangles. Now, if we only look here at this part of the formula, 2 times a half equals 1, so this is really just base times height. And this is the formula that we can use to find the surface area of a triangular prism. Length times the sum of the 3 sides of the triangle plus the base times the height of the triangle. So now that I have a formula for the surface area of a triangular prism, I'm going to practice using it. Again, surface area equals the base times the height of the triangular faces plus the length of the prism multiplied by the sum of the 3 sides of the triangular face. All right, so SA equals, in this picture right here for the base and the height, remember that they're perpendicular to each other. So I can see that this is 50, which matches in the back. This would be 50. And 10 feet, the height is perpendicular to that. So for the base and the height, I'm going to do 50 times 10 plus the length of the prism. The length connects the 2 faces together, the 2 bases together. Right here, I can see that that would be 60 feet. So I'm going to do 60 times the sum of the 3 sides of the triangle. So if I look at the triangular faces, I see right here it has a side of 20 plus this side right here, which is 50, plus this third side, which measures the same as this third side right here, which is 30 feet. Using the order of operations, I'm going to add what's in the parentheses first. So surface area equals 50 times 10 plus 60 times 20 and 50 is 70, plus 30 is 100. Now I'll go ahead and multiply. 50 times 10 is 500, plus 60 times 100 is 6,000, which means that the surface area of this triangular prism would be 6,500 square feet. In the next part of our lesson, we're going to look at the volume of prisms. Okay, surface area in the first part of the lesson dealt with the outside surfaces of the solid. Volume of a solid is going to deal with how much space is on the inside of the solid. And in order to help us calculate the volume of a prism, we're going to use this equation right here. V equals capital B times H. All right, capital B equals the area of the base. So we need to make sure that we know our area formulas. H is going to be the height of the prism. The height is always the measure from one base to the other base. Volume is measured in cubes, so our units will always be raised to the 3rd power whenever we do a volume question. Okay, so again, to calculate the volume of a prism, we have to do the area of the base multiplied by the height. If we're working with a square prism, okay, also known as a cube, I'll try to draw a picture of a cube. It looks something like this. We know that a cube has dimensions called the length, the width, and the height. Okay, to get the measurement of this base down here, I have to do the length times the width. So to get the volume, I'm just going to do the length times the width and then multiply it by the height. So volume equals length times width times height for a square prism. A square prism, a cube, is just a special rectangular prism. So the rectangular prism is also going to be length times width times height. All right, a triangular prism is just going to be a little bit different. So I'll try to sketch my best triangular prism. Okay, if I draw something that looks like this right here. Okay, now we set up here that the height is always what connects the one base to the other. But when our triangular prism looks like this measurement that connects the 2 triangles together is actually going to be the length, which is why here in our formula, it doesn't say h anymore, it says times the length. All right, we need to figure out what the area of a triangular face is and then multiply that by the length to get the volume of the triangular prism. To get the area of a triangle, we know that we have to do 1/2 the base times the height. So on this triangle right here, remember, this can be the base, and the height has to be perpendicular to that. In our next example, we're going to find the volume of the rectangular prism. The rectangular prism measures 11 meters by 3 meters by 7 meters. In order to find the volume, I again use the formula V equals capital B, which is the area of the base, multiplied by the height. And remember, we said back up here to find the area of a rectangular prism's base, we just do the length times the width. So the formula is really just length times width times height. Length times width times height. So V equals, okay, well, I can call 11 meters the length, 3 meters the width, and 7 meters the height. All I need to do then is 11 times 3 times 7, the length times the width times the height. Okay, multiplying here, 11 times 3, that's going to be 33. And then I just have to do 33 times 7, which is going to equal 231. Now the units are meters, and then back up here we said it's measured in cubes, so it's going to be meters cubed, or meters to the third power. 231 cubic meters is the volume of that rectangular prism. In the next section, we're going to look at volume of trapezoidal prisms. A trapezoidal prism is a prism where the base shapes are trapezoids. And just like finding the volume of a triangular prism, when we find the volume of a trapezoidal prism, at the end, we're going to have to multiply by the segment that connects the two trapezoids together, which in this case is going to be the length. Okay, so that's going to be at the end of my volume formula. To calculate the area of the base, the capital B, well, I need to know the area formula for a trapezoid, and fortunately I do. To find the volume of a trapezoid, I do 1/2 the sum of the bases of the trapezoid, base 1 plus base 2, multiplied by the height. Okay, remember that the bases on the trapezoid are the two parallel sides, so that's going to be base 1 and that can be base 2. The height is perpendicular to both of those. Okay, so that would be the area of one of the trapezoids. And then to get the volume at the end, I just have to multiply by L, the length. So this is the formula that you would use to find the volume of a trapezoidal prism. Let's use that now to answer this question underneath. A watering trough is in the form of a trapezoidal prism. Its ends have the dimensions shown. So we're going to use the dimensions in this picture. How long is the trough if it holds 12 cubic meters of water? All right, well, I have a couple of clues here that this must be a volume question because they're talking about holding water, which means the water's inside of the trough. And it also gave the units in cubic meters, which I know is volume. So I'm going to use this volume formula. V equals 1/2 base 1 plus base 2 multiplied by the height multiplied by the length. Now I'm going to substitute in values that I know. I'm going to have my 1/2 here. If I look at my trapezoid, I see it has bases of 1 6/10 and 2 4/10. So I'll do 1 6/10 plus 2 4/10. It has a height right here of 1 2/10. And then L, how long is it? That's actually what I'm trying to calculate, which means they must have given me the volume. And that's actually what they told us right here. It holds 12 cubic meters of water. That's the volume. Okay, so to get the value of L, the length, we're going to actually use our order of operations by adding what's in the parentheses to start. 12 equals 1/2 times 1 6/10 plus 2 4/10. Well, that's just 4 times 1 2/10 times L. Well, half of 4 is 2, so 12 equals 2 times 1 2/10 times L. And I'm just going to bring that up over here. Okay, so 12 equals 2 times 1 2/10 times L. Well, if I multiply 2 times 1 and 2/10, that equals 2 and 4/10. 12 equals 2 and 4/10 times L. So to get the value of L, the length, I'm going to have to divide each side by 2 and 4/10. On the right, that leaves us with L. And on the left, if I do 12 divided by 2 and 4/10, I get 5. So this means that the length is 5 meters. Okay, we didn't find an area, a surface area, or a volume, so the unit is just the given unit that we saw in the picture, which was meters. The length of the trough was 5 meters. Next, we're going to calculate the volume of a triangular prism. Our formula for that, again, is V equals 1/2 the base times the height times the length. The base times the height, that comes straight from the triangular face. And again, the length is what connects the two triangles together. So this segment right here is going to be the length. Okay, this right here, the base and the height have to be perpendicular to each other. Okay, and then all I have to do is multiply those values together. So V equals 1/2 times, okay, well, B equals 7 centimeters, so I know that's 7. H equals 9 centimeters, so that's 9 centimeters right there. And then it gives me P and S. P and S are the two slanted sides of the triangle that aren't the base. So I can call that one P right there, which happens to be 11.5 centimeters. And I can call this one S right here, which happens to be 11 centimeters. Now, neither one of these are needed for this formula because the base and the height have to be perpendicular to each other. And then I need the length, which connects the two triangles together right here, is 15 centimeters. So let's substitute in these values. 1/2 times the base they said was 7, times the height right here they said was 9 centimeters, times the length was 15 centimeters. Okay, well, I can do 1/2 times 7 times 9 times 15. 7 times 9 I know is 63. 63 times 15 comes out to be 945. So now all I have to do is find half of that number, and that gives me a volume of 472 and 5/10. And now the units again were centimeters cubed. 472.5 cubic centimeters is the volume of our prism.